What's up, Algebra 2 students? This is lesson 58. Our objective is, how do you complete the square when the leading coefficient is not 1? Well, I guess first let's talk about what a leading coefficient is. A leading coefficient is whenever you take a quadratic, or any polynomial, and write them in standard form. That's where the exponents go down in order. So this is an x squared, then an x, and then x to the 0th. And it's equal to 0. When those go down, the leading coefficient is the number in front of the variable with the highest exponent. So with the quadratic, it's the number by the x squared. So in this case, it would be 7. For this one, negative x squared plus 7 equals 0. The leading coefficient would be negative 1, because the number in front of that x squared is negative 1. For this last one, x squared plus 31x plus 8, the leading coefficient is just simply 1. So it's really just the number by this x squared term when we're talking about quadratic equations. Also remember how to complete the square. If we had something like this that said solve by completing the square, remember everything with x is on one side, everything without to the other, so I'd subtract 5 from both sides. Purposely leave a space, and I do this little trick where I take this number by the x, divide it by 2, and then square it. So that'd be negative 6 over 2, it's negative 3 squared, add 9, and add that number to both sides here. And then this left-hand side factors into a perfect square. Combine terms over there. And then, since this is squared, remember that you can say this, what's inside here, is equal to the plus or minus square root of that. Okay? The square root of 4 happens to be 2, so I have plus or minus 2. Adding 3 to both sides, I get x is equal to plus or minus 2 plus 3. But of course I can simplify that down. If this had been like the square root of 3, then I would have just stopped right there at that point. Would have been fine, but since these you can actually combine together, I said 2 plus 3 and negative 2 plus 3 is 5 and 1. So that's my solution set right there. I notice this is the positive 2 and the negative 2. So if you don't remember how to do that, pause the video now, go back and find the lesson where we talked about solving by completing the squares. Watch that one, understand that one, and then come back to this, because this is doing the same thing except for with one more step at the beginning. And here's the one step. The book says if the leading coefficient is not 1, then the first step is to divide every term on both sides of the equation by the leading coefficient. The result will be an equation with a leading coefficient of 1. So here we're going to do same thing we did before, except we have one step first. So I'm going to add 6 to both sides. End up with 3x squared plus 5x is equal to 6. I need this leading coefficient right here to be 1. So to do that, I'm going to divide both sides by that number, 3. And if it had been negative, I would have divided by negative 3. So this is going to give me x squared plus 5 over 3x is equal to 2. And again, I purposely left that space right there. So then I'm going to take this number by the x, which is 5 over 3. And then I'm going to write this way. I'm going to divide it by 2, or 2 over 1. And then I'm going to take that answer and square it. Remember, whenever you divide by 2, that'd be like the same thing as saying 5 over 3 multiplied by 1 over 2, which is going to be 5 over 6. So whenever I divide it by 2, I get 5 over 6. So then I'm going to square that. It's going to give me 25 over 36. I'm going to add that number. Okay, so I understand it's not pretty, but you can do it. Don't freak out with the fractions. Just stick with it. You can do that. So this left-hand side now is going to factor to, remember, it's going to be x plus whatever is in here before we square it. So it's going to be 5 over 6 squared is equal to, now we're just going to add those two together. I want to know that 2, if I multiplied it here by 36 over 36, would be 72 over 36 plus 25 over 36, which will then come out to be 97 over 36 is equal to this, x plus 5 over 6 squared. Taking the square root, I know x plus 5 over 6 is going to equal to the plus or minus square root of 97 over 36. This right-hand side simplifies down to the square root of 97 over the square root of 36, just comes out to be 6. So then whenever I add 5 over 6 to both sides, you get x is equal to the plus or minus square root of 97 plus 5 over 6. Or normally we'd probably write it with that plus 5 first. 5 plus or minus the square root of 97 over 6. And if you want to find decimal approximations, that you could, but these are my two exact answers. Let's just try one more of these. I'm going to add 1 to both sides. End up with 3x squared minus x, purposely leaving space, is equal to 1. I want to get that leading coefficient to be 1, so I'm going to divide both sides by 3. Then I obtain x squared is equal to, not equal to, minus 1/3 x is equal to 1/3. I'm going to take that 1/3 here, divide it by 2, which gives me 1/6, and then square it, which gives me 1 over 36. And then I'm going to add that to both sides. If I multiply this one right here by 12 over 12, the left-hand side will come out to be x. In this case, it's going to be minus 1/3, because I should have written this like this. Should have been, sorry, negative 1/6, negative 1/6 squared is equal to 13 over 36. That means x minus 1/6 is equal to the square root of 13 over 36, which simplifies down to the square root, sorry, the plus or minus. The plus or minus square root of 13 over 6. Then I will add the 1/6 to both sides, and I'll end up with x is equal to 1 plus or minus the square root of 13 over 6. Your homework is a worksheet, so make sure you pick that up. Good luck.